Welcome to lesson 2 on binary operation. If you've not watched lesson 1 yet, check the link in the description below so that you get clear understanding of lesson 2. So in lesson 2, we are going to look at 3 things. We are going to discuss the properties of operations. Okay, so the properties we are discussing, we are looking at the commutative property, we are looking at the associative property, then we look at the distributive property. So we will start with the first one, which is commutative property. So what does commutative property say? How do I identify that an operation is commutative property? It is very simple. Commutative property deals with position. Commutative property deals with position. Don't forget, commutative property deals with position. It says that the positioning of a given operation doesn't matter. You will get the same answer. If I have 5 plus 2 is the same as 2 plus 5, both will give me 7. Okay, so commutative property says that no matter how I position the given letters, if it is variables or the given numbers, I should get the same result, or I should get the same answer. Right, so that is what commutative property says. And mostly with commutative property, we are talking about 2 variables if it is variables, or 2 numbers if it is numbers. So A operation B, or 3 operation 5, or A plus B, yes, or 3 plus 5. So we are dealing with 2 letters or 2 variables. Let us not forget, commutative property deals with 1, position, 2. So the position means whichever way we position them. If A comes first and B follows, it should give me the same answer if B comes first and A follows. You will look at it in the next slide. It also says that, or just like I said, we use 2 letters, 2 variables, and 1 operator. 1 operator, 2 variables, 1 operator, 2 variables, 1 operator. So for example, A operation B, the variables are A and B, the operator is the star in here. Okay, so 2 variables, 1 operator, 2 variables, 1 operator. It deals with position. So what it says is that A operation B should be the same as B operation A. It says if I should change the positions, if A comes first and B follows, it should give me the same result if I should bring B first and A follows. For example, if I have 2 plus 3, this will give me 5. If I bring 3 first too, I should get 5. So 3 plus 2 should also give me 5. That is what commutativity is all about. Okay, so without wasting my time, let's jump into the details of it. Alright, so commutative property. It says that A operation B should be equal to B operation A. How do you check that? This is how you check it. You will be given a definition or a rule which we have looked at in lesson 1. So like I said, if you have not checked lesson 1, check it out and then you will get to understand the rule or the definition better. You'll be given a rule or a definition. Use the rule or the definition, solve for A operation B using that given rule. Now interchange the positions. So now B comes first, A follows. Use the same rule to find B operation A. If you get the same answer for the 2, it means the operation is commutative. If you get different answers, then the operation is not commutative. Alright, but mind you, commutative deals with position, it deals with 2 variables and 1 operator. So here the variables are A and B, the operator is star. Then it deals with position. It says whichever way I put it, if I change the positions of the numbers, they should still give me the same answer. 2 times 3, which is 15, which is 10, is the same as, right, I said 2 times 3, okay, 2 times 3 is 6. I thought I said 2 times 5. So 2 times 3 is 6, and that should be the same as 3 times 2, which is also 6. Similarly, 2 times 5 is 10, and that should be the same as 5 times 2, which is 10. 3 plus 9 is 12. That should be the same thing as 9 plus 3, which is also 12. That is what commutative property says. If I change the positions, I should get the same answer. So if I finish solving using the given rule and I get A operation B to be 20, then B operation A also gives me 20. It means the given operation is what? Commutative. But then if after solving A operation B gives me, say, 20, and then B operation A gives me a different thing, which is 21, I've got different answers. 20 and 21 are not the same. So I say the given operation is not commutative under the given rule. Alright, so if I have 5 operation 3, we are saying if I solve 5 operation 3 using the given rule or the given definition, the answer I get should be the same thing if I should change the positions. That is, if 3 comes first and 5 follows. If I finish solving, I should get the same answers. If I get the same answers, then I can say that the operation is commutative. But if I get different answers, then I say it is not commutative. So if 5 operation 3 gives me 11, and then after solving 3 operation 5 2, I get 11, then I say yes, it is commutative. But if after solving 5 operation 3 and then 3 operation 5, I get different answers. Say 5 operation 3 gave me 19 and then 3 operation 5 gave me 15. I say that the operation is not commutative. The operation is not commutative. So let's delve into it. Let's take some examples to help us. But before the example, you have to understand that addition and multiplication are always commutative. Always. Addition and multiplication are always commutative. We will check that out here. So let's prove it. If addition is commutative, when we say addition is commutative, it means if we are adding numbers, no matter how we change the positions, we should get the same answer. For example, 2 plus 5 is 7. If I change the positions and I bring 5 first, 5 plus 2 should also give me 7. And that is true. In all cases, with addition, it is always the same. Let's say if I have 10 and 21, 10 plus 21, this should give me 31. If I interchange the positions, then I get 21 plus 10. It still gives me 31. You can use a lot of numbers and you will get the same answers. This is why we are saying addition is commutative, meaning when we are adding numbers, we can change the positions in whichever way and we will still get the same answer. That being said, let's look at multiplication. We are saying multiplication is also always commutative, meaning if I should multiply numbers, whichever way I position them should give me the same answer. 2 times 4 should give me 8. If I should interchange them and 4 comes first, 4 times 2 is also 8. 2 4, 8. 4 2 is also 8. You can use any number at all and you get the same thing. Okay. So 4 12, so 4 times 12 is 48. All right. If we change the positions, 12 comes first times 4, which follows. 12 4 is also 48. You can use any number at all you like or any numbers at all you like, and you will get the same answers. That is why we are saying addition and multiplication are commutative, meaning if you are adding or multiplying numbers, whichever way you position the numbers, you will get the same answer. Division and subtraction are not. So let's see. If I have 4 minus 2, this will give me 2. But if I change the positions, 2 minus 4 will give me minus 2. You see, 2 is not equal to negative 2. It's not the same as negative 2. So subtraction is not commutative. You can use any number at all. And then we are saying before it can be commutative, no matter the number you use, you should get the same answer. Okay, but with subtraction, you are not always going to get the same answer. Similarly, with division, you are not going to get the same answer. So 4 divided by 2 will give us 4 divided by 2 will be equal to 2. But 2 divided by 4 is half. Okay, but we can see that 2 and half are not equal. They are not the same. So division is not commutative. Similarly, if I have 25 divided by 5, 25 divided by 5, 25 divided by 5 will give me 5. See, 5, 5, 25. So 25 divided by 5 will give me 5. But then if I have 5 divided by 25, 5 divided by 25, that is going to give me half, 1 fifth, 1 over 5, 1/5. 5 divided by 25 is going to be 1/5. 5 into itself, 1 into 25, 5, 1/5. Now, 5 and 1 over 5 are not the same. You can use a lot of numbers and you realize that they are not always going to be equal. They are going to be changing. So, addition and multiplication are always commutative. Division and subtraction are not. So, that being said, let's look at some examples. So, example 1. If A operation B is equal to A plus B plus AB. So this is the rule I was talking about if you have not watched lesson 1 yet. So this is the rule given. Show whether the operation is commutative or not. So we are saying that for commutativity or for an operation to be commutative, A operation B should be equal to B operation A. If you change the positions, they should give you the same answer. How do we check that? First, solve for A operation B using the given rule A plus B plus AB. First one plus second one plus first one times second one. When you are done, you solve the next one after you have interchanged the positions B operation A using the same rule. First one plus second one plus first one times second one. If you get the same answers, then it is commutative. If you get different answers, then it is not commutative. So let's see. Now we quote our rule. Our rule is A operation B is A plus B plus AB. All right. So let's see. A operation B is A plus B plus AB. Because they are non-numbers, we can't simplify further. We can't add A to B. Neither can we add AB to B or A. So A operation B will give us A plus B plus AB. First one plus second one plus first one times second one. Okay. So this is what we get for A operation B. Now we take B operation A and we solve. B operation A is equal to, see, first one, so over here the first one is B, plus second one, which is A, plus BA, which is first one times second one. Over here our first one is B and our second one is what? A. So first one times second one, B times A. Though multiplication is commutative, you can interchange them, but as far as solving is concerned, let's follow the rule. Okay, the definition is saying first one times second one, A, B, A times B. All right, so let's compare if the two answers are the same. A operation B gave us A plus B plus AB. Then B operation A gave us B plus A plus BA. Let's see. So we have A is here, okay, it is here, it is here. We have B, both are positives, so we have B, and then we have AB. See, AB is the same as BA. 2y is the same as y times 2. Let's not forget multiplication, okay, commutative. So 2 times y is 2y, y times 2 is also 2y. So BA is B times A, and then AB is B times A, so they are the same. So since A plus B plus AB is the same as B plus A plus AB, then BA, we say that the operation is commutative. Alright, so since A plus B plus AB, that is what we had for operation B, is equal to B plus A plus BA, which is what we had for B operation A, then we are saying that A operation B is equal to B operation A, which makes it commutative. So A operation B is what? Equal to B operation A. We had the same answer, just that the positions were changed, and then how they were multiplied were changed. But we have already seen that how we change addition doesn't change the result, and then how we multiply numbers also doesn't change the result. So meaning the operation is commutative. Don't worry, we will use numbers to solve, and then we see what we are talking about. So example 2, using the same formula, okay, we are using the same rule, the same definition. It says A operation B is equal to B plus A plus AB. First one plus second one plus first one times second one. We should show whether the operation star is commutative or not, given 5 operation 3. We said for commutativity, or for an operation to be commutative, A operation B should be equal to, so let me write it here, A operation B should be equal to B operation A, right? But over here, what we are using, it says that given 5 operation 3, so the operation we are using is what? 5 operation 3. Okay, so 5 operation 3. We are saying for it to be commutative, when we interchange them, 3 operation 5 should also give us the same answer as we will get for 5 operation 3. So let's solve and see if after solving 5 operation 3, we get the same answer as 3 operation 5, then we say it is commutative. All right, so let's see. So we quote our formula, okay. For commutativity, 5 operation 3 should be equal to 3 operation 5. That is, if we interchange the positions, we should get the same results or the same answer. So what do? First, we find 5 operation 3 using the given rule. Then next, after that, we find 3 operation 5 using the same rule. Then we compare our answers. All right, so we quote our rule again. It's always important to quote your rule. A operation B equals A plus B plus AB. Now you see over here, it is A operation B. A came first, and after the equal to, A came first. A plus B plus AB, meaning the first one plus the second one plus, you see, even the multiplication, the A came first. First one plus second one plus first one times second one, A times B, first one times second one. So we use the same way. So 5 operation 3. So we are following the same rule. Okay. So first one, which is 5, plus second one, which is 3, plus first one times second one, 5 plus what? 3. All right. So 5 times 3. 5 times 3 will give us 15. So always multiplication first. So we have 5 times 3 to be 15. 15 plus 5 plus 6 will give us 23. 23. So 15, or 5 plus 3 plus 15. 5 plus 3 is 8. 8 plus 15, 23. 3. So 5 operation 3 has given us 23. Now let's solve 3 operation 5 and see what we get. 3 operation 5 using the same rule. So 3 operation 5. Now over here the first one is 3, the second one is what? 5. So our first one 3 plus our second one 5 plus our first one times our second one, 3 times 5. Okay, so similarly 3 times 5 is what? 15. So we have 3 operation 5 is equal to 3 plus 5 plus 15. 3 plus 5 is 8. 8 plus 15 is also 23. Meaning, so now you can see 5 operation 3 gave us 23. 3 operation 5 also gave us 23. Meaning A operation B is equal to B operation A. But because you have been given numbers, we say 5 operation 3 is equal to 3 operation 5. Alright, so 5 operation 3 is equal to 3 operation 5. Why? Because both of them gave us 23. This means that the operation is commutative. This means that the operation is commutative. So if after solving you get different answers for the two, then we say the operation is not commutative. Let's check another example. Example 3, using variables. Then example 4, we use numbers. So if P operation Q equals P plus 2Q, let's show whether the operation is commutative or not. So it is the first one, P plus 2 times Q, 2 times the second one. Are we there? So for commutativity, P operation Q should be equal to what? Q operation P. So for commutativity, P operation Q should be equal to Q operation P. That is, we have interchanged the positions. We are saying that for it to be commutative, if you finish solving the two, we should get the same answer. They should be equal. If they are not, then it is not commutative. If they are, then it is commutative. Now we have to quote our rule or definition. So our rule is P operation Q is equal to P plus 2Q. So since this one too is variable and not numbers, P operation Q is equal to P plus 2Q. We can't simplify further. We can't add 2Q to P. So P operation Q is P plus 2Q. So now the next thing is to solve for Q operation P. So Q operation P, that is the first one. See the first over here, the first one is P. So P came first. Okay, but over here the first one is Q, so Q comes first. You have to check that too very well. So Q operation P is equal to the first one, which is Q, plus 2 times the second one, so 2 times P. Alright, so we can simplify that one too further. So let's compare. P operation Q gave us P plus 2Q. Then Q operation P gave us Q plus 2P. Are they the same? Let's see if they are the same. P, we have P there, but then over here we have 2P. See, P and 2P are not the same. Then we have Q here. We have Q over here, but this one is 2Q. Q and 2Q are not the same. P and 2P are not the same. So P plus 2Q is not the same as Q plus 2P. So since P plus 2Q is not equal to, so this is not equal to, okay, not equal to. So P plus 2Q is not equal to Q plus 2P. This should be P, okay. It's not equal to Q plus 2Q, 2P. So we are saying that since P plus 2Q is not equal to Q plus 2P, then Q operation P is not equal to P operation Q, or P operation Q is not equal to Q operation P. If they are not equal, then we say it is not commutative. So therefore the operation over here is not commutative. That is that. All right, so let's use the same definition, but this time around we are using numbers. Example 4. If P operation Q equals P plus 2Q, show whether or not the operation over here is commutative or not. So the or not has come. So show whether or not the operation is commutative given 5 operation 3. So using 5 operation 3, solving with this rule or definition, we should decide whether the operation is commutative or not. So let's delve into it. For it to be commutative, P operation Q should be equal to Q operation P. But over here you have been given the operation, that is 5 operation 3. So it's going to be 5 for commutativity, or for it to be commutative, 5 operation 3 should be equal to 3 operation 5. Before it can be commutative, if you solve 3 operation 5 using the rule, it should give us the same answer if we solve 3 operation 5 using the same rule. So now let's see if that is the case or not. So for commutativity, 5 operation 3 should be equal to 3 operation 5. So now we solve the first one, 5 operation 3, using the given rule or definition. When we are done, we solve the second one, that is, we change the positions. But there is the need to quote our rule or definition. So P operation Q is equal to P plus 2Q. First one plus 2 times second one, the 2 is constant. Alright, so 5 operation 3, let's solve. 5 operation 3 should be equal to the first one plus 2 times the second one, the 2 is constant, okay? 2 times the second one. 2 times 3 is going to give us 6, right? 2 times 3 is going to give us 6. So 5 plus 6 is 11. So 5 operation 3 is 11. 5 operation 3 is 11. 5 operation 3, 11. So let's solve 3 operation 5 now that we are done with 5 operation 3 using the same definition or rule. Then we compare the answers. Alright, so 3 operation 5 is equal to the first one. So over here, the first one was 5, right? But this very one, the first one is what? 3. The second one is 5. So the first one, 3, plus 2 multiplying the second one, which is 5. So 3 plus 2 times 5. We solve multiplication first. So 2 times 5 is 10. So 3 operation 5 is equal to 3 plus 10. 3 plus 10 will give us 13. Okay, so 3 operation 5 is what? 13. 3 operation 5 is 13. Now let's compare the two answers. 5 operation 3 gave us 11. And then 3 operation 5, that is after changing the positions, we had 13. So we have got two different answers. Because the answers are not the same, because you have got two different answers, we say that the operation is not commutative. Because you have got two different answers, we say the operation is not commutative. One gave us 11, the other one after changing the positions gave us 13. So they are not commutative. So 5 operation 3 is not equal to, so this is the sign you are seeing there. Okay, 5 operation 3 is not equal to 3 operation 5 because 11 is not equal to 13. So 11, because 11 is not, or since 11 is not equal to 13. Okay, all right. Therefore, the operation is not commutative. Always don't forget to bring the operation. Therefore, the operation is not commutative. All right, that being said, let's look at the next property, which is associative property. Associative. We have said commutative property deals with two variables, one operator. Variable being A and B, or B and C, or M and N, whichever. Then one operator. Okay, so we can see over here we had two variables, P and Q, then one operator, the operator here. Okay, then the previous one, same. We had A and B, then the operator was star. Okay, but with associative property, we are dealing with three variables. So A, B, and C, A, B, and C, or L, M, N, or D, E, F. Three variables, and then one operator, but that operator appears two times. One operator appearing two times, one operator appearing two times, one operator appearing two times. And then we said commutative property deals with changing the positions. When you change the positions, you should get the same answer. But associative property doesn't deal with changing positions. It deals with groupings. Associative property deals with what? Groupings. Associative property deals with groupings. Alright, so after grouping them, you should get the same answer. If I group the first two, I should get the same answer as grouping the last two. Associative property deals with grouping, that is one. Two, associative property deals with three variables. If it is numbers, three numbers. Then one operator, which appears two times. But sometimes they will try to confuse you. With variables, they will give two. Then you'll be asked to prove whether it is associative or not. You should know that I should get three variables. So if they give you A and B, you should add C automatically. If you are given M and N, you should add O automatically. Okay, so whenever you are given two, you should make sure it becomes three when solving. If you are given three, then you solve with that straight away. Alright, so let's move into it. Associative property. This is what we are saying. I'm saying three. So for example, A, operation B, operation C. Now you can see that I have three variables, A, B, and C. Then I have one operator, which is the star. The star is one, but it has appeared two times. You see, same operator appearing two times. All right. Then we say if I group the first two, the answer I get should be the same if I group the last two. You see, if I group the first two, I have to solve the first two first. If I group the last two, I have to solve the last two first. So what we are saying is, if I group the first two, the answer I get should be the same if I group the last two. If that is so, then it is associative. If it is not, it is not associative. If I get different answers, it is not associative. All right, so let's delve into it. So I have L operation M operation N equals L operation M operation N. But you can see over here, I group the first two. I have three alphabets, three variables, three letters. Okay, have three letters. One operator appearing two times. I've grouped the first two. Okay, we are saying that if we group the first two, it should be equal to grouping the last two. If that is true, then it is associative. If it is not true, then it is not associative. associative. So if L operation M operation N, grouping the first two gives me 45, and then grouping the last two also gives me 45, then the operation is associative. But if grouping the first two gives me a number, say 32, and then grouping the last two gives me a different one, say 45, then the operation is not associative. All right, so if I have 2 operation 3 operation 5, it should, grouping the first two, okay, should be the same as 2 operation 3 operation 5 with the last two grouped. So first two grouped equal to last two grouped. If it is true, then it is associative. If it gives me different answer, then it is not associative. So if 2 operation 3 operation 5 with the first two grouped gives me 37, and then the last two groups also gives me 37, I say that the operation is associative. But if grouping the first two gives me a different answer from grouping the last two, so say grouping the first two gives me 40, then grouping the last two gives me 72, what we are saying is that operation is not associative. It is not, because the answers are not the same. It is not associative. So you can see throughout that we are having 3 letters or 3 numbers. 2 are grouped. So with the left hand side 2 are grouped. At the right hand side 2 are grouped. Then we have one operator appearing 2 times throughout whatever we are doing here. All right. So let's take now some examples. But before the examples, addition and multiplication are also associative. Addition and multiplication are also associative. I think there was a typing mistake. I made it commutative. No, it should be associative. So addition and multiplication are associative, just like the commutative property. Addition and multiplication are associative. So let's see, they are always associative, meaning if I have, so let's try addition. 2 plus 3 plus 7. If I group the first two, the answer I get should be the same as grouping the last two. So let's see. 2 plus 3 is 5. 5 plus 7 is 12. So 12, let's have it in mind. That is grouping the first two. We had 12. So the same numbers, grouping the last two, will it give us 12? So let's solve. Parentheses first. So 2 plus 3 plus 7 is what? 10. 10 plus 2 is 12. You see, it also gives us the same thing, 12. You can try a lot of numbers and you should get the same answer. Always the same. Always the same. Now multiplication is also associative. 2 times 3 times 5. If I group the first two, 2 3 is 6. 6 times 5, 6 5 is 30. All right, we had 30. Let's have it in mind. Now if I group the last two, I should also get 30. So I have 2 times, I saw what is in the parenthesis or bracket first, which some call bracket, but this is parenthesis. 3 5 is what? 15. Okay, 15 times 2 or 2 times 15 is 30. Right, so you can see, you can try a lot of examples and each one of them will give you the same answer. So you can pick any 3 random numbers and then do the addition or multiplication, first grouping or last groupings. Every time you should get the same answer. Unlike the division and subtraction, which sometimes you get the same answer and sometimes you get different answer. If it is not always the same, then it is not. Okay, so subtraction, for subtraction I think it's always false. So let's have 2 minus 4 minus 3. If I group the first two, 2 minus 4 is what? Minus 2. Minus 2 minus 3, that should give me minus 5 or negative 5. Negative 2 minus 3 is what? Negative 5. Now, we had negative 5. Let's have it in mind. Let's have it in mind. We had negative 5. Alright, so let's group the last two, 4 and 3. So we solve what is in the parentheses first. 4 minus 3 is 1. Okay, 4 minus 3 is 1. So 2 minus 1 will give us 2, which is different from the answer we had early on. Okay, which was negative 5, I think. Yes. So negative 5 is different from 2. So you see, we didn't get the same answer. That's why we are saying subtraction is not associative. It's only addition and multiplication that are both commutative and then associative. Subtraction is not. You can try a lot of numbers. Even if one of them gives and the rest don't give, it is still not associative. Before it becomes associative, it should always be equal. So 5 minus 1 minus 1. Let's group the first two. 5 minus 1 is 4. 4 minus 1 is 3. Okay, let's group the last two. So grouping last two, okay, we have 5 minus 1 minus 1 is what? 0. 5 minus 0 is 5. So you see, different. So subtraction is not associative. Let's look at division. Division. All right, so division is also not always associative. So division is not associative. It's not associative because it will not always give us the same answer. It is not associative because it will not always give us the same answer. Let's try 4 divided by 2 divided by, say, 2. We group the first two. 4 divided by 2 is 2. Now 2 divided by 2 will give us 1. Okay, let's group the last two and see. We had 1. Let's group the last two. Alright, so 4 divided by 2 divided by 2 is 1. 4 divided by 1 is 4. You see, we had different answers. So it is division is also not associative. Division is also not associative. Then let's try another one. 3 divided by 2 divided by 6. So let's group first two. 3 divided by 2 is still 3 over 2, which you can change to decimal. 3 over 2, right, divided by 6. So 3 over 2 divided by 6 is going to be 3 over 2 times 1 over 6. That is reciprocate. 3 over 2 divided by 6. 3 over 2 divided by 6. That is going to be 3 over 2 times 1 over 6 reciprocate. Okay. Alright. So 3 can cancel 6, or we multiply straight away. So 3 1 is 3. Then 6 2 is 12. 3 dividing 12. 3 into itself, 1 into 12, 4. So we get 1 over 4. So this gives us 1 over 4. Let's group the last two. So we have 1 over 4. Let's group the last two. Was it 6? Yes. Let's group the last two. Alright, so 3 divided by 2 over 6. 2 over 6. Sorry, 2 divided by 6. Sure, which is the same as 2 over 6. That's going to be 1 over 3. 1 over 3. Because 3 2 is 6. 1 over 3. So this is going to be 3 over 1 times 1 over 3. 3 over 1 times, 3 over 1. Grouping, reciprocating. 3 divided by 1 over 3. We reciprocate. Okay, when you have division of fractions, you reciprocate. So you will get 3/1. So you repeat the first one. Every whole number is over 1, so 3/1. Division changes to times. Then you interchange them. So 3 moves up. The numerator becomes the denominator, and the denominator becomes the numerator. So we get 3/1 times 3/1, which is 9. Okay, so it is also different. We had different answers, so it is not associative. Now I want you to check something here for you to understand why I'm saying if you don't always get the same answer, then it is not. Because there are times where you can get same answers, but it should be every time. If once a while you get the same answer and the rest you are not, you try some digits, you get the same answers, but others you don't get, it means it is not associative. Now let's try this one. Let me see if I will get this. I remember this. That was 6 divided by 3 divided by 1. Okay, is it 2 or 3? Right, let's try this one and see. If it is not this, I'll change it, because I remember there's one question that will give us the same answer. So let's group the first two. 6 divided by 3 is going to be 2, because 3 to 6, 2. 2 divided by 1 will be 2. So grouping the first two, we had 2. Let's see. Next one. So we group the last two. So we repeat our 6. So 6 divided by 3 divided by 2 is 1. 3 divided by 1, sorry, is 3. 3 divided by 1, the one in the parenthesis, is what? 3. Now we have 6 divided by 3, and that will give us 2. 3 to 6. So you see, this one we had same answers, but the ones that we've solved gave us different answers. So the fact that one gave us same answers and then the rest are not giving us same answers still makes it not associative, because before it can be associative, it should always give us the same answer. All right, so this is what I wanted you to know, why I was saying always same. All right, so let's look at examples. So example 1, if m operation n equals m plus n plus mn, show whether or not the operation is associative. So like I said, you see, you have been given two variables. With the operation, or let's say with the definition, you're always going to be given 2, but you should know how to solve it. Okay, you should know how it's going to be solved. You should understand that no, associative, I have 3 variables. So if m operation n is equal to m plus mn, show whether or not the operation star is associative. So now let's move into it. Don't forget that associative, you should get 3 variables. If it is numbers, 3 numbers, 1 operation sign appearing twice. So let's delve in there. So that is why in your books you can see A operation B, but then in solving you will see C in there. This is why associative always has 3 variables or 3 numbers. Okay, if it is numbers, you always be given 3. Okay, if it is numbers, you will always be given 3. But if it is variable, then they can try to skip. All right, so for associativity, m operation n operation o, you see, you were given only m operation n, but then you do have to continue with the next one. Okay, so after n, what follows? O. So m and o. If it is a and b you were given, you continue with c. If it is c and d you were given, you continue with the next one, which is e. Okay, so you should not forget. All right, so for associativity, m operation n operation o should be equal to m operation n operation o. First 2 in one parenthesis, and then the last 2 in another parenthesis on the other side of the equation. If they are the same, then we will say that it is associative. Yes, if they are not the same, then it is not associative. So how do we do that? We solve this using the given operation or given rule. Let me put it well. Using the given rule or given definition. After that, we solve this one too. That is the other grouping, the other side of the grouping, using the same rule or definition. Then we compare our answers. If they are the same or if they are equal, then we say that our operation is associative. If they are not equal, our operation is not associative. You ask yourself, I have only M and N. Why? But I have O here now. How am I going to solve it? It's very simple. First, you deal with what you have in the parentheses before you come to the O. So for now, let's deal with the first one. All right. So we first quote our rule or definition. As I keep saying, we quote our rule or our definition. So M operation N is equal to the first one. This is what you should always keep in mind, not even the letters, okay? What you should keep in mind is the first one, C, M, plus second one, N, plus MN, which is plus the first one times the second one. I keep saying that the first one because there are times where you see M operation N is equal to maybe N plus M, then that should tell you, okay, the second one plus the first one, but this one is first one plus second one. All right, so M operation N, good. So now we deal with what is in the parentheses first. Let's first put this one aside, okay, the operation O aside, and then we solve what is in the parentheses first, just like we looked at in the first video. Okay, you deal with what is in the parentheses first, then you are going to get one thing, then you apply it using the other one. All right, so M operation N operation O is equal to, so we deal with what is in the parentheses. So what is in the parentheses? M operation N, first one plus second one plus first one times second one. Then we repeat our operation O because we are not yet there. We have to finish the one in the parentheses before we get to the other operation. So we are not yet there. So we repeat it. So that is it. Then we continue. M operation. So that is what we did. M operation N plus. Now because they are variables, you see, we can't add M to N. And we can't add Mn to N. Neither can we add Mn to M. So meaning this is 1 now. So this is now 7 as our M. And this is 7 as our N. See, if they are numbers, we could have added them or maybe multiplied them, but because they are variables, this is 7 as our M. Okay, operation. So you can see there is no operation in this one. Let me clear. Okay, good. You can see. So you solve until you get 1. There's no operation. So there's no operation in it. So it becomes 1. Then operation, the next one, which is O. So we deal with that. So we are saying the first one plus the second one plus Mn, which is plus the first one times second one. Now this 7 as our first one. This 7 as our second one. So it's going to be first one, which is M plus N plus Mn, okay, plus second one. Our second one is O, okay, plus first one times second one. Our first one is what? M plus N plus Mn, okay, times the second one, which is O. So you see, the whole of this is our M, our first one, M, plus our second one, N, but over here O is representing the N, plus first one times second one. Okay, that is what the rule said. That's what the rule said. You can go back and check the rule. So plus first one times second one. And we are saying that the whole of this is our first one. So plus the first one times our second one, which is what? O. So you can put times in the middle. There's nothing wrong. Okay, times O. Or because the bracket is 7 as times, that's why I didn't bring the times. So that's how it's going to be. Okay. All right. So this is it. So the whole of this is the first one plus O, which is the second one, plus the first one, the whole of this is the first one times our O, the second one, because the operation sign is gone now. The operator is gone, so the whole of this is now our M. It's 1. It's 1 now. If it is numbers, we could have got one digit, but because they are variables, it's 1 now. 1. We are treating it as 1. All right, so let's move on. So we now simplify. Okay, we are expanding now. So m plus n plus mn over here, we have removed the parentheses, plus o, which is here. Then you see the whole of this times o, meaning o is multiplying m, o is multiplying m, o is multiplying n, and o is multiplying mn. So that is what we are going to see at the next slide. So m plus n plus mn plus o. Then o times m is mo. O times n is no. Then o times mn is mno. Okay. All right. So m plus n plus mn plus o is repeated over here. Then o times m is mo. O times n is no. Then o times mn is mno. Alright, so we just group them. So I decided to group them. So m, n, o. See, m comes before n before o, so I group them in that order. Then mn, see, n comes before o, so mn plus mo plus no, because m comes before n, plus mno. So I'm just grouping them. Okay, m plus n plus o, which is here, plus mn over here, plus mo. Okay, plus no plus mno. So just grouping. So grouping them, group them. All right, so that is that for m operation n operation o with the first two grouped. Now we go to m operation n operation o with the last two grouped, that is n and o. Okay, so that one too, the n will serve as our first one, which is m. The o is serving as our second, which is n. Then the m will be aside. We finish with the parenthesis, then we come to m. Very, very simple. Right, so m operation n operation o. Now the last two in parenthesis. All right, so because there is operation sign here, we repeat it. We deal with the one in the parenthesis first. Okay, the rule is saying first one plus second one plus first one times second one. So because you are dealing with the parenthesis first, now I just repeated the m here. Okay, so just like we looked at in lesson 1, you can decide to put the m away. You deal with the parenthesis first, then you bring the m. What you get, you bring the m, then you solve m operation. What you get in the parenthesis, then you solve. Or you can bring it as you solve along. Make sure you don't forget. All right, so we are solving the one in the parenthesis first. So first one, which is n, plus second one, which is o, plus first one times second one. So first one, which is n, times second one, which is o. All right, so now if you look at what is in the parenthesis, we can simplify further. See, we can't add O to N, neither can we add NO to O or N. So the whole of this N plus O plus NO becomes our second one. You see, the M is the first now here. Okay, so M becomes our first one, and the whole of this becomes our second one. So we solve with the whole of that. Okay, sorry for... Okay, so here we go. All right, so since we have done one just few minutes ago, let's see. So we have first one, which is our M over here, plus the second one, the whole of this, so that is here, plus that, plus the first one times the whole of the second one, so plus first one, which is M, times the second one. Now the whole of this is our second one, so times the whole of that. Okay, all right, so we get M plus N plus O, just removing brackets. So M plus N plus O, we have removed the parentheses, so M plus N plus O, yes, plus NO. Okay, plus NO, we are just removing the parentheses from that side, plus now M is multiplying everything in the parentheses, so we have M times N, which is MN, then M times O, which is MO. Okay, then M times NO, which is MNO. All right, so that is rearranging. So M plus N plus O, then MN is here, MN is there, and then plus MO. See, N comes before O, so plus MO is here, then NO is here. Okay, then our MNO is also here, just grouping them. Okay, you can even leave them whichever way, but I decided to group them. So as a good mathematician or math student, you are supposed to group them nicely. Now let's see. Let's see this very well. M plus N plus O plus MN plus MO plus NO plus MNO. Let's compare with the previous one and see what we had. M plus N plus O plus MN plus MO plus NO plus MNO. You see the same thing. You can write it down as I show the next one. Right, so I'm showing the next one. Now you can see this is the next one, and they are the same. So because they are the same, after grouping the first two, what we had, and then grouping the last two, we have got the same answers, meaning the operation is what? It's associative. The operation is associative. So since M operation N operation O grouping the first two is equal to M operation N operation O grouping the last two, since they are equal, we are saying that the operation is associative. All right, now let's use numbers and then see what is next. So example 2, we are using numbers using the same rule. Okay, the same rule, the same definition. Let's delve into it. Now the given operation is 2 operation 3 operation 5, so that should be equal to 2 operation 3 operation 5 with the second two grouped. All right, so let's delve into it. Quote your rule for associativity. Let's go. For associativity, what you have been given, 2 operation 3 operation 5, the first two grouped, should be equal to 2 operation 2 operation 5, the last two grouped. So we first solve this one, the first two grouped. When we are done, that is using the rule over here. When we are done, we solve this one with the last two grouped using the same rule, and then we compare the answers. If the answers are the same, they should. That if the answers give us the same things, or if the answers are the same, then we say that it is associative. If the answers are different, then we say it is not associative. All right, so let's delve into it. So like we did with the variables, you deal with what is in the parentheses first. So over here we are dealing with 2 operation 3 operation 5, the first two groups. So we start with the ones in the variable. So the rule says first one plus second one plus first one times second one. Our first one is 2 plus second one plus first one times second one, 2 times 3. Then our operation 5, which is here. So when we are done with the one in the parentheses, then we add this operation 5 to it. So again, like I said in the previous lesson 1, you can put this aside. When you are done solving, after you get your single number for this, you add operation 5. You can still solve it together this way if you don't want to forget. All right, so 2 plus 3 is what? 6. 2 times 3 is 6. Then 2 plus 3 is 5. So 5 plus 6 will give us 11. So we have 2 operation 3 operation 5 should be equal to 11 operation 5. Okay, 11 operation 5 because the 11 is for only the one in the parentheses, 2 operation 3. That's what we have done here. 2 times 3 is 6. 6 plus 3 is 9. 9 plus 2 is 11. So 11 operation 5. So now we are done with what is in the parentheses. We have got 11 for what is in the parentheses. So now it's going to be 11 operation 5. Okay, so 11 operation 5. So 11 operation 5 should be equal to, still using the same definition, the same rule. First one 11 plus second one 5 plus first one times second one, 11 times 5. So 11 5 is 55. 11 5 is 55. So 11 operation 5 is equal to 11 times 5, which is 55, plus 5 plus 11. So 55 plus 5, that is 60. 60 plus 11, that is going to be 71. All right, so 11 operation 5 is equal to 71. So 2 operation 3 operation 5 is 71 because 2 operation 3 operation 5 is the same as 11 operation 5. Why? 2 operation 3 gave us 11. Okay, then our operation 5 is also there. So 2 operation 3 operation 5 is equal to 71. 2 operation 3 operation 5 is 71. So now let's solve 2 operation 3 operation 5 with the last 2 in parentheses and see our answer. Then we compare. Let us not forget our answer here. It is what? 71. All right, so let's go. So now the last 2 in parentheses. So we solve the last 2, the ones in the parentheses first. Okay, so we repeat this one, or we can put it aside. When we are done with the one in the parentheses, we deal with that. If you want to understand that one, just check the link in the description below for lesson 1, and then you will understand better. All right, so first one, which is 3, plus second one, so 3 plus second one, which is 5, plus first one times second one. First one is 3, second one is 5, so 3 times 5. Now 3 5 is what? 15. So we have 3 plus 5 plus 15. Okay, so 3 plus 5 plus 15. All right, so that is 3 5 is 15. Okay, so 3 plus 5 plus 15. 15 plus 5 is what? 20. 20 plus 3 is 23. So I solved it straight away. I wanted you to see, that is why I went back. So that is going to be 23. So the whole of this 2 operation 3 is what? 23. Then we don't have to forget our 2 operation. So we now have 2 operation 23. So we solve 2 operation 23. So still using the same rule or definition. First one, so 2, plus second one, which is 23, plus first one times second one, 2 times 23. So 2 times 23 is going to be 46. So 2 times 23 is what? 46. So 2 plus 23 plus 46. 2 plus 23 plus 46 is going to give us 71. So take your time and add them. 2 plus 23 is going to be 25. 25 plus 46 is 71, because 20 plus 40 is 60. 6 plus 5 is 11. So we are going to get 71. So comparing these answers, 71 to the one we had, this one is 71. The one we had was also 71, meaning 2 operation 3 operation 5 is 71. That means that since 2 operation 3 operation 5 first 2 grouped is equal to 2 operation 3 operation 5 last 2 grouped, since they are equal, since they give us the same answers, that is 71, we say that the operation is what? Associative. Therefore the operation is associative. All right, so I have a trial example here. Try this and let's see. This is going to give you non-associative. Okay, it's not going to be associative. It says x operation y is equal to x squared minus y. So for associativity, x operation y operation, guess, good, let's go, z associativity, those what? 3. Okay, so that is it. You would have to bring that. So you see the question gave x and y, x operation y, so you have to make sure that you add the last one, which is z, then you group the first 2. Okay, then you say for associativity this should be equal to x operation y operation z. Okay, now grouping the last 2, then you use this definition to find it. All right, so you try it. Okay, try it. Let me see if I can in a way help. So x operation y operation z, the first 2 grouped. So x operation y is saying x squared minus y, first one squared minus second one, so x squared minus y. Okay, operation z, the z is there. Okay, now you see we can't simplify this further. Since we can't simplify this further, meaning this whole expression is now our first one, and then the z is our second one. So x squared minus y operation z. X squared minus y operation z. Then the question is saying, let us not forget the whole of this is our first one, then the z is our second one. The rule is saying that x operation y is x squared minus y. Now the whole of this is our x, and then the whole of, and then the z is our y. Now this is our x, this is our y. So it says the first one squared minus the second one. So first one squared minus second one. So x squared minus y squared. Okay, minus second one, which is z. So this is going to be x squared minus y multiplying another x squared minus y minus z. Okay, so I'll entreat you, take your time, you solve it because of time, and then the space of this video. Take your time, solve it. When you are done, use it to evaluate this one. I have a number. Okay, have a number here. We said it's not going to be associative, so I have a number which solving will be very easy. Okay, you use it to simplify this. 2 operation 7, 2 plus 7 plus 5. Okay, I should have made it 2 operation 7. Okay, so 2 operation 7 operation 5. So solving this will be very simple. This one is going to be a lot, but solving this will be very simple. It says that it's going to be, so we solve the one in the parentheses first. Don't worry, I will solve this one, the ones without the numbers, in the video because of the time. Then I'll post it, or if anything I'll just solve it and then put a photo of it. Right, so it says first one squared minus second one. So in the parentheses, first one squared minus second one. Okay, then our operation 5. See, I made it plus, make it operation. Okay, all right, so 2 squared minus 7. 2 squared is 4. Because of the space, I'll be cleaning often. So 2 squared is 4. So I have 4 minus 7. Then operation 5. So 4 minus 7 will give us minus 3. Okay, minus 3. So we have minus 3 operation 5. So you see, the one in the parentheses has given us 1 digit, which is minus 3. So we have minus 3 operation 5. So we solve using the same rule, minus 3 operation 5. Alright, so minus 3 operation 5 is going to be minus 3 squared minus y, because minus 3 is 7 as the x, then 5 is 7 as the y. So it's going to be minus 3 squared, that is x squared, minus 5, which is minus what? Y. Alright, so minus 3 squared minus 5. Minus 3 squared. Don't forget the minus 3 is for all the x. Okay, minus 3 squared minus y, which is our 5. Minus 3 squared is going to be 9, positive 9, because the negative is also squared. So 9 minus 5, and that should give us 4. So we had 4. Okay, put it in mind, we had 4. I didn't want to solve because of time, but let me help you. So we had 4. Now let's group the last two and see what we get out of it. For this one, try and solve, but then I'll solve it and put a photo of it, or maybe I'll make it a video. That will take a lot of time because it is variables. Alright, so now let's group the last two. 2 operation 7 operation 5. Last 2 grouped. So that's going to be our 2 operation is going to be repeated. So we are going to get in the parentheses 7 squared minus 5. Okay, that is y squared minus x squared minus y. Our x is what? 7. Our y is 5. So 7 squared minus 5. So 2 operation 7 squared minus 5. 7 squared is 49. Okay, 7 49. So 2 operation 49 minus 5. Right, so 49 minus 5 is going to be 44. 44. So we have 2 operation 44. Right, so now we've got one or single digit, or let's say one number. Okay, not a single digit, it's a one number, 44. All right, so 2 operation 44. So now our x is 2, our y is 44. So we have 2 squared minus 44. 2 squared minus 44. 2 squared minus 44. 2 squared is what? 4. So 4 minus 44, 4 minus 44. So 4 minus 44 is going to be negative 40. Negative 40. So you see, the first one we had 4. The first one we had 4. And then this one we have got negative 40. 4 is not equal to negative 40. So it is not associative. It is not associative. Okay, it is not associative. So you can try this. As I have said, I will do that as well. Alright, so let's get to the last property, which is distributive property. Now, distributive also has 3 variables. If it is number, it has 3 numbers. Okay, so if it is variable ABC or MNO or PQR and the likes, it has 3 variables, just like the associative. But the distributive has 2 different operators. The associative has 3 variables but 1 operator appearing 2 times. Distributive has 3 variables but 3 variables but 2 operators. 3 variables but 2 operators. With the distributive, you have 2 different variables, 2 different operators. Okay, 2 different operators with 3 variables or 3 numbers. All right. Now the distributive sharing. So you share this over that, sharing. It's very simple. Now we are saying that, so you can see 1, 2, 3, A, B, and C are the variables. Then the operators are star and then this operator here. Alright, so that is distributive. So it has 3 variables and then 2 different operators. Now we are saying that for an operation to be distributive, A operation into parenthesis B operation C, that is different operations, should be equal to A operation in one parenthesis operation, that is a different operation, A operation C in another parenthesis. Now this is why it is distributive. So A operation B, so you see the operation star is distributive over this operation over here. Distributive, just like we are sharing it. So operation star is distributive over the operation over here. So you can see it is shared for A and B and then A and C. One operation for A and B and C. So the operation outside the parentheses is always found inside the 2 parentheses, and then the one inside the parentheses becomes the one in the middle. Now it will be very simple if I go to the proof. Okay, very, very simple. With the distributive property, what it says is this. So within few minutes we look at the proof, then you get to understand very well. Distributive property says that if I add what is in the parentheses or I subtract, then I multiply by a number outside the parentheses, is the same as multiplying the number outside the parentheses by each one of the ones in the parentheses. Let's see what I'm talking about. I have 2 times 3 plus 2. We are saying this should be the same as 2 times 3 plus 2 times 2. Okay, so now you can see the one in the parentheses is now in the middle. That's why the one in the parentheses here is in the middle. And then the multiplication sign outside here is now found inside. The multiplication sign outside here is now found inside the 2 parentheses. That is why the operation sign outside is now found inside the 2 parentheses. We are saying that we can solve this very question in 2 different ways. One, adding what we see in the parentheses and then we multiply the answer by 2. So let's see. 3 plus 2 is 5. 5 times 2 is 10. Or we share the numbers, distribute, okay, distribution. We distribute the numbers in the parentheses, okay, using the one outside. So this multiplies this. So let me do it nicely. Okay, so 2 multiplies 3 plus 2 multiplying 2. See, just like you do expansion of bracket is the same thing, expansion of parentheses. That's what distributive is all about. So distributive is all about expansion of parentheses. It says that, well, if I solve the one in the parentheses straight away, then I multiply by what is outside. It's the same as expanding, multiplying what is outside by the individual items in the parentheses. It should give me the same answer. Okay, so the one outside multiplies both ones inside, not forgetting our addition sign. So A multiplies B. So because the operation sign is over here, I'm using multiplication. It's all, that side is always multiplication. It's always. So I've gone back. Okay, good. So the first one here is always multiplication, always, just like this is always multiplication. Okay, so A times B, which we have here, plus, okay, it can be minus as well, A times C. Okay, so that is it. So if I do it like that, when we solve straight, we had 10. So 2 times 3 is 6. 6 plus 2 times 2 is what? 4. 6 plus 4 is 10. See, that's what distributive is about. If I solve what is in the parentheses and I multiply by what is outside, it should be the same answer as expanding, distributing the numbers to the one outside. Okay, expanding, distributing the numbers to the one outside. 3 is given to 2, and then 2 is also given to 2. Distribution, okay, expansion of the parentheses. So distribution has to do with expansion, but then it has 3 variables and then 2 different operators. All right, so let's see. So what it means, so what we are saying is, just like we did, and then each one of them we had 10. If I solve what is in the parentheses straight away and I multiply by what is outside, and then I get 10, then I expand 2, then I get 10. I expand, I distribute for them, I expand the parentheses, and I still get 10. Because I got the same answers, we say that it is distributive property. The operation is distributive. Alright, so you see, it's also very, very simple. Distributive property is also very simple. If I deal with what is in the parentheses, then I multiply my answer by what is outside, or I expand them. If I get same answers, then it is distributive. But then if after dealing with what is in the parentheses and then multiplying my answer by what is outside, I get a different answer after I have expanded, or dealing with the parentheses straight away, multiplying by the parentheses, and then expanding them gives different answer, then we say that the operation is not distributive. Okay, and always, how do we do it? I've already said it is done by picking the first one. So in this case, this one, using the given operation, the given definition to solve. Then you pick the second one as in the expansion side. Then after the distribution has been done, then you use the same definition or rule to solve. When you are done, compare the two answers. If the two answers are the same, it is distributive. If they are not the same, it is not distributive. So because this one, the two answers are the same, distributive. Because they are not the same over here, not distributive. Because 13 and 10 are not the same, not distributive. All right. So if I have 4 operation 2 operation 6, it should be 2 operation 4, the one outside, operation the first one inside, okay, then operation 4 outside, operation 6 inside over here, not forgetting my operation sign here in the middle, right? So just like 4 times 2 plus or minus, okay, I'm saying plus or minus because it can be plus or minus 4 times 6. That is all, very simple. So if both give me the same answer, so 4 over 5, then it is distributive. But if they don't give me same answer, say 4 over 5, 2 over 3, they are not the same, then we say it is not distributive. All right, so now let's look at proof. So before the proof, we are saying that multiplication is distributive over addition and subtraction. Just like I said, the one outside is always multiplication, okay, and then the one inside is either addition or subtraction. Always the one outside is multiplication, the one inside is either addition or subtraction. So we say multiplication is distributive over addition and subtraction. Let's check that. Proof: multiplication over addition. So 2 times 4 plus 2. So multiplication is distributed over addition. Okay, multiplication distributed over addition. Multiplication works on over addition. All right, so let's see the first one. 4 plus 2 is 6. So 6 times 2. 2 6 is what? 12. All right, so now let's see. Let's distribute and let's expand. 2 times 4. So 2 times 4. Then plus, see my plus sign is here. Plus 2 times 2. See the first one I had 12. So 2 times 2. All right. Now 4 times 2 plus 2 times 2. 4 times 2 plus 2 times 2. 4 times 2, which is 8, plus 2 times 2, which is 4. 8 plus 4 is what? 12. You see the same answers. Multiplication over addition. You can use any numbers and you still get the same answer. Right. So let's say 3 times 1 plus 4. So 1 plus 4 is 5. 5 times 3 is what? 15. 3 5 15. Or we expand 3 times 1. 3 times 1. First one I had 15. Let's not forget 15. Then plus my plus here. 3 times 4. 3 times 4. So I have 3 times 1 plus 3 times 4. 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 All right. So 3 times 1 is 3. Plus 3, 4, 12. 3 plus 12 is 15, just like we had. You can try a lot of numbers. You are going to get the same answer. So it's just the normal expansion we know. That is what the distributivity is about. Okay, that's what the distributivity or distributive property is about. Then multiplication over subtraction. I will solve only one. You can try other examples. 2 times, I said the one outside is always times. 2 times 3 minus 1. So 2 times 3 minus 1 is 2. So 2 times 2 will give us 4. Now let's expand 2 and see. So 4, let's expand 2 and see. 2 times 3, that is 2 times 3. Then this one minus 2 times 1. Minus 2 times 1. 2 times 3 minus 2 times 1. 2 times 3 minus 2 times 1. 2 times 3 minus 2 times 1. So 2 times 3 is 6 minus 2 times 1, which is 2. 6 minus 2 is what? 4, just like we had. Okay, so but mind you, the one outside is always, so when you are writing it like this, the one outside is always multiplication, but the one inside is either addition or subtraction. So when you expand, what is outside now becomes inside the 2 parentheses, and what is inside the 1 parenthesis becomes in the middle, or comes to the middle of the 2 parentheses. All right, we know this already right from crèche, right? Yeah. All right. So now let's see. We are saying that multiplication is distributive over addition and subtraction only. It is not distributive over multiplication. It's not distributive over division. So let's see. Multiplication over division. So 2 times 4 divided by 2. So 4 divided by 2 is 2. 2 times 2 is 4. So that gives us 4. Let's see. 2 times 4. Then what is in the middle? Okay, in this case, division. What is in the parentheses is division, so it comes into the middle. So divided by 2 times 2. 2 times 2. All right, so let me clear this space. So 2 times 4 divided by 2 times 2. 2 times 4 divided by 2 times 2. 2 times 4, 2 times 2. So 2 times 4 divided by 2 times 2. 2 times 4 is 8 divided by 2 times 2. 2 is 4. Okay, so now we have 8 divided by 4. We know 4 will divide itself 1 into 8, 2. So 4 divided by 8 is 2. But then when we solved directly or straightforward, we had 4, but this one is 2. So you see different answers. So division, multiplication over division is not distributive. Then we see multiplication over multiplication. It sounds strange, eh? Yes, multiplication over multiplication. So 2 times, so multiplication over multiplication. The over is the one. So the second one is what to be found in the parentheses. So 2 times 3 times, say, 2. So solving straight away, 3 to 6, 6 to 12. So solving straight away, we get 12. So 12. Now let's distribute. 2 times 3 times 2 times 2. 2 times 3 is 6 times 2 to 4. 6 4 is what? 24, which is different from 12. So 24 is different from 12. So we say when what we see, when the operation sign in the parentheses is multiplication, it can be distributive. When it is division, it can be distributive. It can only be if there's multiplication here and then addition or subtraction in here. That is that. All right. So that being said, let's delve into examples. So example 1. If A operation B equals A plus B minus AB, where A and B are real numbers, show by evaluating A operation into bracket A plus C and A operation B plus A operation C whether or not the operation is distributive. So when you check well, you'll be forced to say it is distributive because the plus in the middle here is in the middle here. The operation outside is now found in the two operations in the two parentheses. So just a look at it will let you think it is distributive because A distributed over B, which we have here, then A distributed over C, which you have here. But no, you don't just look at it like that. Just like I've said, you solve, okay, using the given definition, the given rule that will help you to identify. So let's first solve this. Then when we are done, we solve that. Then we compare the answers. So now there are two operation signs indirectly. One is here. Let me show you. One is here, which is definitely going to be multiplication, and then the one has been given already as addition. We have said it is that one is either addition or subtraction, and it has already been given. So there are two. And then we have operation signs, variables that are A, B, and C. All right. So let's delve into it. So we state our rule, and then we state our condition for distributivity. Okay, so our rule is A operation B equals A plus B minus AB. First one plus second one minus first one times second one. Then for distributivity, or our condition for distributivity, A operation B plus C into parentheses should be equal to A operation B in parentheses plus A operation C in another parenthesis. So if it will be distributive, then this, after solving using our rule, this should be equal to that. If they give us that answer, same answer, then it is of course distributive. If they give us different answers, then it is not distributive. All right, so let's delve into it. So we are starting to solve with A operation B, A operation into parentheses B plus C. Now you can see over here there is no operation. This is not operation. Okay, it's like they have already solved for us. We can't add B to C, so we can't simplify further. So the whole of this is 7 as 1. So now our A is the first one, then B plus C is the second one. The rule is saying first one, so our first one A, plus second one. Now the whole of this is our second one, so plus our second one, minus the first one times the second one, so minus our first one is A times our second one, which is the whole of this. So that's what we have there. Oh my goodness, I've gone very far again. Okay, I'm here. All right, so let's move on. So we expand this side. Negative A times B is negative AB. Negative A times C is negative AC. Then we over here to remove our parentheses. So that is what is next. So A is here, B plus C is here, parentheses removed. Negative A times B is negative AB. Negative A times C is negative AC. Then we check if there is anything we can add or subtract, or we can group like terms. Then we move on. We can't add ABC. We can't subtract AC from AB. so we can't simplify further. So this is the answer for A operation B plus C into parentheses. So now let's try the expanded form and see if it gives us the same answer. So the expanded form. Now you can see with the expanded form, this is an operation. And this is also another operation, meaning we have to solve what is in each of the parentheses. So the first parenthesis will be solved using the rule. The second parenthesis will also be solved using the rule. Okay, so that is how it goes. We solve what is in the just like we keep saying, if you see 2 operation, 3 operation, let me use the same operation. Operation 4. So you solve what is in the parentheses first. But over here, we have 2 parentheses. So it's the same thing. We are solving the 2 parentheses simultaneously at the same time. Okay. So we solve the parentheses together. Because both are parentheses, we solve them together. So in the first parenthesis, it is the first one plus second one plus first one times second one. So first one, A plus B minus, okay, so it's minus rather. Let me check the rule again. Okay, it's minus A times B. Minus A times B. Alright, so first one, which is A, plus second one, which is B, minus first one times second one, A times B. Okay, so this is for the first parenthesis. Then our plus sign is here. Then we solve the second parenthesis, which is A operation C. So the A is representing first, C is representing the second. So first one plus second one, A plus C, minus first one times second one, so minus A times C. Alright, so we just remove the parentheses, then we move on. So A plus B minus AB here, parentheses removed, plus here, A plus C minus AC, A plus C minus AC is here, parentheses removed. Then we check if there are some we can add or there are some we can subtract and the likes. So yes, we have like terms in here. I can see A here and A here. So I have A plus B plus C. Then I have minus AB, then minus AC. Okay, A plus A will give me 2A. So I'm going to get 2A plus B plus C minus AB minus C. Don't worry, it should be to be displayed just like I've said. Right, so A plus A is 2A. Then B is alone, so plus B plus C is here, minus AB is here, then minus AC is also here. So the 2 A's have been added to get 2A. All right. Okay. So that is that for A operation B into parentheses plus A operation C into another parenthesis. Now, if we compare with the previous one is A plus B plus C minus AB minus AC. But the other one has 2A plus B plus C minus AB minus AC or so, something like that. So, are they the same? No. This is A. The other one has 2A. So, they are not the same. They can't be the same. So, comparing the two, we have 2A plus B plus C minus AB minus AC. But the previous one is A plus B plus C minus AB minus AC. which means they are not equal. So a plus b minus ac minus c, which we had in the first one, is not equal to, that's a symbol in the middle over here, is not equal to 2a plus b plus c minus ab minus c. This one, what we had for this. So since they are not equal, it means the operation is not distributive. All right. Then example number 2. Example number 2 is saying that two binary operations. So you see the two operators have appeared. Two binary operations, star and this very one, are defined over the set R of real numbers by x operation y is equal to xy. So wherever you see the operation star, it means its rule is xy, the first one times the second one. And x operation y, the operation that looks like a circle, its rule is x plus y. So when you see the operation that looks like the circle, it means the first one plus the second one. The star is the first one times the second one. The circle is the first one plus the second one. Show whether or not the operation star is distributive over this operation. See, because the star will come first, the star will be outside. That's why I'm saying if the star is distributive over the other one. So the star will be outside, then this one will be inside. All right. So solution. So we quote our definitions or our rules. X operation y equals xy, that is first one times second one. Then x operation y, the second one, is first one plus second one. All right, so let's delve into it. For distributivity, you see it says the operation star is distributive over the operation, the one that looks like a circle. Okay, let me say the operation circle, right? Meaning the circle will be inside because the star is distributive over the circle. Always multiplication over the one inside, the addition or subtraction. Multiplication over, so you see multiplication over, and then multiplication is always outside. So distributive, star over, so star outside. That is why you can see the star outside over here. Good. So for distributivity, x operation into parentheses y operation z, see the two different operations have appeared. See, we're given x and y, but then we should know that distributivity also has to do with what? 3 variables. So you were given x and y, add the next one, which is z. All right, you can add any other variable, but it's advisable you add the next one if there is. All right, so we are saying for distributivity, x operation into parentheses y operation z should be equal to x operation y operation x operation z, that is the expansion. Okay, solving it straight away should be equal to solving it after the expansion. If it is, then it is distributive. Then the operation star is distributive over the operation circle. If not, if they are not equal, then it is not distributive over it. All right, so let's delve into it. So we first pick this one, we solve using the given rules. Then later we pick this one, we solve using the given rules. Then we compare our answers. So always you compare the answers after solving to be able to determine whether it is or it is not. Right, so we always deal with what is in the parentheses first. So what is in the parentheses is what? Y operation z. And the operation here is which one? The one that looks like a circle. So we come and check the rule for the one that looks like a circle. It says x operation y should be equal to x plus y, meaning first one plus second one. So over here, our first one is y, our second one is z. So that is y plus z. Now we can't add y and z, so y plus z becomes 1. It's like a single one because we can't add y to z. If they are numbers, you could have added them, but because they are not numbers, we can't add them. So y plus z now stands as 1. So x now becomes our first one, and then y plus z becomes our second one with the operation what star. So we go back to the star, which says first x operation y equals xy, which is first one times second one. So our first one is x, our second one is what? Y plus z. So x is going to multiply y plus z, just like the operation is saying, because we are dealing with the star now. We are done with the circle, so we are dealing with star. Right. So that is first one times second one over here. Okay, first one times second one. Our first one is x, so it's here, times our second one, which is what? Y plus z. Right, so x times y is xy, then x times z is xz. So it's going to be xy plus xz, xy plus xz. So we are done with this very one. So now we go to this, the expansion, the expanded form, using our rules given. Then we compare our answers. All right, so that is it. So we have x operation y, operation x, operation z. Now you can see we have two parentheses now. So always with the expansion, we will have two parentheses and you have to solve them along, because we solve parentheses first, but over here we have two parentheses, so we solve them simultaneously. So we deal with x operation y and then x operation z at the same time. What does x operation y say? The rule says that first one times the operation, okay, the star says first one times the second one. Let's go back there, check. You see the star says first one times second one, so we go to the star, it says first one times second one, so it's going to be x times y. Then the second parenthesis is going to be x times z. Okay, good. So yes, it has been done over here. I've done it over here. So xy, which is x times y, first one times second one. Then the operation in the middle is here. Then the second parenthesis, x operation z, that is x times z, is also here. All right, so meaning x. Then now we have xy operation xz. Xy is now 1, so that is the first one, and then xz is another one, which is the second one. Now we have the operation circle, which says first one plus second one. So first one, which is xy, plus second one, which is xz. So it's going to be xy plus xz, xy plus xz. So that is that. So comparing the first one and the second one, you can see they are the same. So since they are the same, this one, solving it straight away, solving the one in the parentheses straight away, multiplying by the one outside, and then expanding will give us the same answers. So since they give us the same answers, we are saying this is equal to that. If it is equal, then we are saying that the operation star is distributive over the operation circle. All right, so let's look at last example number 3. Still we are using the same definitions. Just like we used in the previous one. Okay, but this time around we are using numbers. So given 3 operation to parenthesis 6 operation 2, right? So we quote our condition for distributivity, which states that 3 operation, so 3 operation 6 operation 2 should be the same as guess. All right, your guess is right. So which is the same as 3 operation, see the one outside now comes inside, operation 6, see distribution, then the one inside now comes out, operation 3, operation 2. If your guess wasn't right too, no problem, take your time, you'll get it. Right, so we first take this one, we solve using the given rules, then later we take this one, we solve using the given rules. If you get the same answers, then the operation is distributive. If it is not, then it is not distributive. All right, so let's delve into it. So let's quote our definitions or our rules and then our conditions for distributivity. So our rules, just like we used in the previous example, our condition for distributivity, 3 operation 6 operation 2 should be equal to 3 operation star 6 into parentheses, then operation circle into another parenthesis, 3 operation star 2. All right, so we take the first one, we solve using the rules, then later we take the second ones. All right, so we always deal with what is in the parentheses first. So what do we have in the parentheses? 6 operation 2, and the operation here is what? The circular one. So we go to the circular one, which is first one plus second one. X operation y equals x plus y, which means first one plus second one. Our first one is 6, our second one is 2, so 6 plus 2, which will give us 8. Then we will get 1 digit, then we will continue. So you have 6 plus 2, which is now what? 8. So now we have 3 operation 8, 3 operation 8, 3 operation 8. So we now solve using 3 operation 8. So now this operation is what? The star. So we refer to the star, which says xy. So first one times second one. So 3 operation 8 should be first one, which is 3, times second one, which is 8. So 3 times 8. 3 operation 8 is 3 times 8. So 3 times 8 should be 24. 3 times 8 should be 24. So let's have that in mind. 24. So now let's solve the next one. So this one, that is after the expansion, we are going to solve 2 parentheses along. The operation is what? Star, and the star is saying times first one times second one. So 3 times 6, and then in the second parenthesis, first one times second one, 3 times 2. So 3 times 6 is 18, and then 3 times 2 is 6. So we have 18 operation circle 2 6, sorry. So 3 times 6 is 18, and then 3 times 2 is what? 6. So now we have 18 operation 6. Now the operation is a circular one, which says first one plus second one. So 18 plus 6. 18 plus 6. Right. Now 18 plus 6 is what? 24. 18 plus 6 is 24. 24. All right. So 24. Did we get the same as the previous one? Yes. So it is what? Distributive. The operation star is distributive over the operation circle. But then in the previous one, show you the previous one. In this very one, it was also distributive, right? Yes, because we had the same answers, xy plus xz, which is the same thing here, xy plus xz. And then in example 1 it was not. Okay, in example 1 it was not. not, because they were two different answers. All right. Okay, so now this is distributive because we had the same answers, 24, 24. All right, so this brings us to the end of today's lesson. Today we have looked at commutativity or commutative property. I've looked at associativity or associative property, then distributivity or distributive property. In the next lesson, we are going to look at other three properties. Okay, we are going to look at other three: closure, we look at inverse elements, then we look at identity elements. So closure property, identity element, and then inverse element. All right, so until we meet again, all the best in your studies. So prepare for the next lesson, which will talk about closure, identity, and then inverse. That will be lesson number 3. Then lesson number 4 will talk about tables. How do you even use tables? When you are given a table, how do you identify whether this is closure, it is commutative, associative, distributive? So that will be the next video or lesson. Will talk about these ones: closure, identity, inverse. Then the other one will talk about those tables. All right, so enjoy till we meet again. Bye bye.